We're going to look at this idea of compound angles with trig. Now to start off with, I'm going to derive the first of our formulas. I'm going to do that using the unit circle. So circle, radius 1. There's a point P on our circle. Now I could work out its coordinates if I know the angle it makes at the centre there, because it is radius 1. So I could do a little bit of trig and go, well hang on, x over 1 would be the cosine of beta. So the x coordinate must be cosine beta. Y over 1 will be the sine of beta, so therefore the y coordinate is sine beta. So there's my coordinates for P. Now they will be the coordinates of any point on the circle, as long as I know that angle at the centre. So if I put another point over here on the left, let's call it Q, and that angle is alpha, then the coordinates must be whatever the cosine of alpha is for the x value and the sine of alpha for the y value. Now you might be looking at that and thinking, but hang on a sec, the x value needs to be negative, it's over in the second quadrant. But remember, it's referring to the angle here, and alpha is obtuse, and the cosine of alpha would give me a negative number. So whilst it doesn't look like it, cosine alpha is actually a negative number. Okay, so why have I done all that? Well, I want to find the distance between P and Q. So I could do it via trig, our cosine rule. So I know PQ squared will be 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of, well, the angle would end up being alpha minus beta, that triangle there. Tidying that up, I get 2 minus 2 cosine alpha minus beta. Another way I could have done it was using the distance formula, so coordinate geometry. So I could have said the difference in the x value is squared plus the difference in the y value is squared. And if I expand that all out, ooh, look at that. But there's a bit of tidying up there because I've got a cos squared alpha plus a sine squared alpha. We know that's going to be 1. And I've got a cos squared beta plus a sine squared beta. We know that's going to be 1 as well. So it becomes 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Now I have to confess to you, I fibbed. I'm not actually interested in the length of PQ at all. What I am interested in is PQ squared. Those two things have to be the same. There were different ways of working out PQ squared. So from there, I can say, well, that means 2 minus 2 cosine alpha minus beta must be 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. And if I play around with that, we get the first of our results. The cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. You see, if you have got the cosine of, say, x plus y, the temptation is to just say, oh, that's cos x plus cos y, and you expand out. You can't do that with trig. So this is why we've got these, what we call compound angle formulas. And what I'm going to do now is replace beta with negative beta. So I get cosine of alpha plus beta, with cos alpha cos negative beta, plus sine alpha sine negative beta. Now I'm going to play around with odd and even functions. Okay, we know that cosine was an even function, so the cosine of negative beta is the same as cosine beta. Sine was an odd function, so I know that sine of negative beta is equal to the negative sine of beta. So I substitute that in. Cos of alpha plus beta is cos of alpha cos beta minus sine of alpha sine beta. If you look at them, they're very similar. They both start off with cosine alpha cosine beta. They end with sine alpha sine beta. The only difference is the sign in the middle. When I had a minus, I end up with a plus, and when I have a plus, I end up with a minus. So I could sort of summarize it all in one like that. So cos of alpha plus minus beta, cos alpha cos beta minus plus. So all we've got to remember is change those signs around. It's going to be different. Of course, the way I prefer to remember it is to simply go cos cos sine sine, you see, because we know that pattern will be the same in both of them. Cos cos sine sine. If it's not the sine, no, it's not the sine, it's cosine. then it's not the sine. See? So it's not plus minus, it's minus plus. So that's how I remember the cosine formula. Cos, cos, sine, sine. If it's not the sine, it's not the sine. Now, this time we're going to replace alpha with 90 minus alpha. So I get cos of 90 minus alpha minus beta is, well, cos, we just saw it goes cos, cos, sine, sine. If it's not the sine, it's not the sine. But cosine of 90 minus alpha and sine of 90 minus alpha, I can simplify those down because we know they're complementary ratios. So we'll get, well, the cos of 90 minus alpha plus beta becomes the sine of alpha plus beta. The cos of 90 minus alpha becomes the sine of alpha. And the sine of 90 minus alpha becomes the cosine of alpha. So we end up with sine alpha cos beta plus cos alpha sine beta. And now I'm going to replace beta with minus beta and come up with the other formula. So sine of alpha minus beta will be sine alpha cos minus beta plus cos alpha sine minus beta. Again, I will play with odd and even functions and we'll get sine of alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. So this time, the sign stays the same. See, if it's plus minus, it stays as plus minus. So how I would remember this one, I would go, oh well, that's sine cos, cos sine. If it's the sine, which it is in this case, you beauty, then it's the sine. See, sine doesn't change. So cosine, cos, cos, sine, sine. If it's not the sine, it's not the sine. And sine becomes sine, cos, cos, sine. If it's the sine, it's the sine. So how do I remember which way to start with? Well, you start with whichever one that you've got. So when I was doing the cosine one, the first thing I said was cos. When I'm doing the sine one, first thing I said was sine. And the other thing you've got to remember is whenever you say cos again. So, cosine. Cos. Well, hang on, I just say cos, so I say cos again. Cos. So I've said cos twice, that leaves me with sine, sine. So cos, cos, sine, sine. If it's not the sine, it's not the sine. Now we do the sine one. We go sine, cos. Oh, I just said cos. So I'll say cos again. Cos, sine. If it's the sine, it's the sine. Voila. Well, let's try and create tan. So tan, well, we know tan can be rewritten as sine over cos. And we now know the formula for sine. It is, of course, sine, cos, cos, sine. If it's the sine, it's the sine. And then on the bottom of the fraction, we have cosine. And we now have a formula for that one.
Sine, sine. If it's not the sine, it's not the sine.
There you go. Cos, cos, sine, sine. If it's not the sine, it's not the sine. Well, that's looking pretty tricky to remember. So I'm going to make it look even more complicated. So I'm going to divide everything by cos alpha, cos beta. And you're probably sitting there thinking, what? Are you mad? No, there's method in this madness. Because look, all sorts of things cancel. On the top, you got a cos beta cancels with a cos beta, and then in the next fraction, a cos alpha cancels with the cos alpha, and then on the bottom, cos alpha with the cos alpha, cos beta with the cos beta, and then of course, sine on cos is tan, and look what we get. Tan of alpha plus beta is tan alpha plus tan beta on 1 minus tan alpha tan beta. All right, no prizes for guessing what I'm going to do now, because we've got to work out the minus one. So let's replace beta with minus beta. So tan of alpha minus beta becomes tan alpha plus tan minus beta on 1 minus tan alpha tan minus beta. Tan, odd or even? Odd. So we know the tan of minus beta is the minus tan of beta. So we get tan alpha minus tan beta on 1 plus tan alpha tan beta. The pattern's the same, but all we've got to remember with this one is the sign on top matches what we're doing. So we'll get tan of alpha plus beta is tan alpha plus or minus. So the top one, the sign stays the same, but on the bottom one, the sign changes. So how would I remember that one? Well, of course, it's simply tan plus tan on 1 minus tan tan. Tan plus tan on 1 minus tan tan. So I just remember the plus one, and then if it's minus, I know, oh, okay, the signs go the other way around. But I always just remember this one as tan plus tan on 1 minus tan tan. So we now have our 3 results. Cosine, cos, cos, sine, sine. If it's not the sine, it's not the sine. And so I just said the cosine one, didn't I? So sine, sine, cos, cosine, if it's sine, sine. And tan, which is tan plus tan on 1 minus tan tan. They are what we call the compound angle formulae. So let's just summarise all 3 of them. There they are in all their glory. But this now allows us to expand parentheses with trig. So for some insane reason, we wanted to expand the cosine of 2 alpha minus 3 beta. We go, oh, it's cosine. I know how to handle that. That's cos, cos, sine, sine. If it's not the sine, it's not the sine. And there's our answer. Cos 2 alpha, cos 3 beta, plus sine 2 alpha, sine 3 beta. Simplify this. Temptation is to go to our calculator and see what happens. But if you look at it, it's got one of the patterns we recognise. Look, it's tan plus tan on 1 minus tan tan. So therefore that must be the tan of 20 plus 10, which is 30. That's one of our exact values. Tan of 30, 1 on root 3. Find the exact value of sine 15. So now we can work out exact values for other angles. All we've got to do is rewrite 15 in terms of the ones we know. We know 0, we know 30, we know 45, we know 60, we know 90. So we've got a few possibilities there. How can you get to 15 using those numbers? Sorry, what was the one you went for? 40, what was it, 40? You could go 45 minus 30. How else could you do it? 60 minus 45. So there's all sorts of ways you can do it. Which way did I go? I went 45 minus 30. Sine. Oh, that would be sine, cos, cos, sine. If it's the sine, it's the sine. So now we're substituting our exact values. So 1 on root 2 times root 3 on 2 minus 1 on root 2 times a half. And there's an exact value for sine 15. Root 3 minus 1 on 2 root 2. Sine alpha is 2/3. Cosine beta is 1/4. Find the sine of alpha plus beta. Well, I'll draw up a triangle for each of those. So there's alpha, work out the other side, root 5. There's beta, bit of Pythagoras, root 15. Sine, sine, cos, cos, sine. If it's the sine, it's the sine. Now all I've got to do is read off my triangles and substitute in the particular ratios, and we come up with an answer of 2 plus 5 root 3 on 12. Don't make the mistake of thinking alpha and beta are in the same triangle. In this case, clearly they're in different triangles. Okay, they're not necessarily going to be in the same triangle. The tan of the inverse sine of 2/3 plus the inverse cos of 1/4. It's really the same question, but instead of putting alpha and beta there, we've actually specified what they are. So inverse sine of 2/3, well, let's just say that's alpha. Remember, inverse trig represents an angle. So I'm going to say inverse sine of 2/3 is alpha, and I'll draw a triangle up, really the same as I just did. So if that's alpha, 2/3, other side, root 5. I'll let beta be the inverse cos of 1/4. Let's draw a triangle for that one. Beta, 1 over 4, other side, root 15. And so now we're really just saying, what is the tan of alpha plus beta? Tan plus tan on 1 minus tan tan. And we just substitute in from our triangles. Ooh, that looks ugly. let's multiply everything by, well, root 5 will get rid of the fractions on a fraction. Eventually I got there. Why I put that step in, I don't know. That just makes it look really ugly, doesn't it? I mean, really, I should have just 2 times root 5, bang, 2, and that would have been quicker. But anyway, multiply everything by root 5, and we have an answer. All right, 17D, where you do get to enjoy the excitement of saying sine, cos, cosine. If it's a sine, it's a sine. Or cos, cos, sine, sine. If it's not the sine, it's not the sine. Or tan plus tan, or 1 minus tan, tan. In fact, you could challenge each other and see who could say them the quickest.